In this video clip, we're going to take a look at how to balance a nuclear reaction, and I'm going to show you two examples here. The first example, let's think about what we've been talking about, and we see an isotope of uranium. We're going to call this the parent nuclide, and we see that it has 92 protons. We understand that for whatever reason, this isotope is unstable, and it's going to break down to try to become more stable. When it breaks down, I can see right here that there's something produced, and I'm not sure what that something is, and I see also that I have a thorium isotope over here. Let's go back to 8th grade science here, and let's think about this. You have 92 protons right here. Well, whatever we start with, we have to end with. And if I start with 92 protons, that means that on this side of the equation, I must end with 92 protons. Well, I see that I have 90 protons right here. I know that I started with 92, which means whatever this isotope is right here must have 2 protons. Well, now you've got to pause and think. What is the only element on the periodic table that has 2 protons? We know that hydrogen has 1 proton, so we come across and we know that helium has 2 protons. And so I'm going to go ahead and put in an He here because I know that the only element that has an atomic number of 2 is helium. So 2 plus 90 is 92. Up here, I have 235 particles in the nucleus, which means between these two mass numbers, I have to also have 235 particles. So think of it like this. 231 plus what number? What number goes right here that's going to equal 235? And we know that that number would be 4. 231 plus 4 would give us 235. So now I have a balanced nuclear reaction, have the same number of protons on each side, have the same number of nuclear particles on both sides as well. This again would be an example of alpha decay because when we look at this, what type of particle is being given off? An alpha particle. So that would be an alpha decay reaction. Let's look at the second one that I had in your notes. We see an isotope of aluminum. What am I doing? And we see that it is bombarded with a helium particle. We're not sure what goes here. And then we also see that phosphorus is produced. So this is the nuclear reaction that we're given. Again, let's kind of talk through this. We see aluminum here that has 13 protons. We see an alpha particle here with 2 protons. So 13 plus 2 is 15 protons. There are 15 protons on this side of the equation. Notice that that arrow is always going to kind of cut our equation in half. Well, if I have 15 protons on this side of the equation, that means I must also have 15 protons on this side. So what number plus 15 equals 15? 0. There has to be a 0 right there. Now, let's look at the top. 27 plus 4 is 31 equals what number? I don't know what number goes right here. Plus 30. And you know that would be a 1. 30 plus 1 is 31. So a 31 is going to go right there. Excuse me, I'm not functioning tonight. 1 is going to go right there. So what particle has a mass of 1 but no charge? And that would be a neutron. Okay. So let me kind of erase all this. You can see that finished product. That's what we would have. We see an aluminum combining with an alpha particle produces a neutron and phosphorus. And now that that nuclear reaction is balanced. Okay, let me know what questions you have.